Okay, this is the practice test for MAC1140 Precalculus. We're talking about the topics on exam 3, which covers sections 11.1 through 11.6. In this video, I'm going to be doing numbers 1 through 28 from the practice test. Okay, so let me transfer number 1 over to, let's see what it says to do. You see that you have a system here, a system in only two variables, x and y, and you're being asked to use the method of substitution. So not my favorite method. I like elimination better. I just think it's a lot quicker. But just to demonstrate substitution for those of you that have a preference for that, and just in case I ask you to do a problem by that method. So you have x plus 7y is equal to -2, and then 3x plus y is equal to 34. Okay, so when you're doing substitution, the first step is to isolate for any variable you want. You can either isolate one of the equations for x or isolate one of the equations for y. Okay, specifically, you are going to want to go after a variable that has 1 as a coefficient if that's available. And there is. You have an x that has a coefficient of 1. You have a y that has a coefficient of 1. So either one of those would be good. I'm going to solve for x. So in using equation 1, and I'm going to isolate for x, which means all I have to do is bring this 7y to the other side, at which point it would be -7y, and I'll just move over that -2. Okay, then the next thing you're going to do is substitute. You're going to take this expression, which stands for x, and you're going to substitute for this variable that you just isolated. So now I'm going to substitute for x, but in the other equation. Not the one that you isolated for x in, but the other one. Okay, so using equation 2, and I'm going to plug this in for x. So 3 times x, and I'm plugging in -7y minus 2. The rest of that equation goes plus y equal to 34. Okay, then I'm going to distribute to get rid of the parentheses, so that'll give me -21y minus 6. Drop down that positive y, the equal sign, and the 34, and then solve for y. So when I combine -21 and +1 on my y's, I'm going to have -20y. I'm going to bring this -6 to the other side, at which point it's going to be +6. 6 combined with 34 is 40. Then I'm going to divide this -20 coefficient right off of the y. And I end up with y is equal to -2. So I have half of the solution. I need its x partner. So once you get one of the values, either x or y, you're going to substitute again, only this time not an expression, but rather the value that you just found. Substitute y equal to -2 into either equation. Okay, so I think if I'm going to be substituting this value in for y, that means I'm going to be solving for x. So it'd be nice if you chose an equation that has an x in it with 1 as the coefficient, because it'd just be easier to solve for x. Okay, so I'm going to use equation 1, which is x plus 7y equal to -2. X plus 7y equal to -2. Okay, that's equation 1. This will be x minus 14. Positive 7 times negative 2 is negative 14. That's equal to negative 2. Bring this negative 14 to the opposite side, at which point it becomes positive 14. Negative 2 plus 14 is 12. And now I have a complete pair by the method of substitution. And you can put them together like this. You can report them separately. If you write them as an ordered pair, x goes first, y goes second. Okay, so as far as the answers go, 12 for x, negative 2 for y. So 12 for x, negative 2 for y, and that would be D. Okay, moving to number 2. I'm not going to write all the steps out this time, but I will demonstrate them. I'm not going to write out all the words because I think we know the steps. Okay, so for number 2, we have 1/5 x minus y equals negative 4/5. And then the bottom equation is x plus 8y is equal to negative 4. First thing you're going to want to do is clear out the fractions in equation 1. So I'm going to consider the fact that this denominator is 5 as well as this, so just multiplying by a 5 will clear out both of those denominators so that you won't have any fractions in that equation. So 5 times 1/5, these 5's would cancel, leaving you with 1x. And then 5 times negative y, negative 5y. And then 5 times this, just imagine if the 5 was right here, again the 5's would cancel, leaving you with negative 4. Okay, bring that other equation over, which is x plus 8y. So I'm going to line these up. Take a look at them again. Now you're still in the batch of problems, even though, like I said, I prefer elimination. I think it's quicker, easier, but some people do like substitution, so you can go with that. If you're going to do substitution, you need to start off by isolating one of the equations for either x or y. Now, it's in your best interest to isolate for x here, and you can either do it for equation 1 or equation 2. I'm going to isolate x in equation 1, which would give me x is equal to, I'd be bringing this over here if I plan on getting the x by itself, and it would end up being positive 5y. And then the negative 4, I'm not really moving it, just scooting it over. It remains on the right-hand side. Okay, once you've isolated for a particular variable, now you're going to go substitute into the other equation. And you're going to substitute this expression in for x, but in the other equation. So the second equation down below is x plus 8y equal to negative 4. And you're plugging in this expression that you created in step 1 for x. It is equivalent to x. All right, now you have an equation just in terms of y. You have nothing but y in that bottom equation, so you can solve for y. So 5y plus 8y would be 13y. There's a negative 4 there, and a negative 4 on the right-hand side as well. Okay, I'm going to be adding 4 to each side in order to move this negative 4 over here. Or you can just think of it as when you move it to the other side, it becomes positive 4. Okay, that's adding 4 and adding 4. It would make this go away, leaving you with just 13y is equal to 0. Now divide off that coefficient of y so that it is completely isolated. 0 divided by any number is 0. So we now know half of the answer. We know that the solution for y is equal to 0. Now, go to choose either equation. It could even be one of these ones that transform, but just in case the there is the possibility of making a mistake from here to here as you clear out the fractions. You might want to pick one of the original equations and preferably not the one with the fractions. So I'm going to use this equation right here, x plus 8y equal to negative 4. So x plus 8y, but I already know what y is equal to negative 4. That's the same thing as x plus 0, which is x, is equal to negative 4. And so now I have the other half of the solution. So x is negative 4, y is 0. And I have demonstrated problems 1 and 2 by the method of substitution. Next, we're going to move into numbers 3 and 4. Again, we have another two-variable system in problems 3 and also in 4. For quite a few of these on this first page, we only have 2 variables. And then we'll move to the ones with 3 variables in number 9. So this time I'm going to be doing elimination. Okay, this is number 3. This is the original system, which is 5x plus 6y is equal to 60. Okay, then the equation below it is 5x plus 2y is equal to 80. And when you're doing elimination, you want your x's lined up, your y's lined up, like variables should be lined up. And you try to get one of them to go away. Now in this case, in order for them to eliminate each other, you're going to be adding the two equations together. So the only way you can add two terms together, two like terms, and have them completely cancel is if one's a negative and one's a positive with that same coefficient, just opposite signs in front of whatever variable you're going to try and get rid of. The easiest thing to do would be to go after the x's. So I'm going to try and get rid of those. First, I'm going to create a negative down here. You can create the negative here or here. So I'm just going to multiply everything in the bottom equation by negative 1. That'll make it negative 5x, negative 2y, and negative 80. All it does is switch the signs of each and every term when you're multiplying by negative 1. So now I have coefficient of negative 5x in the bottom equation, coefficient of positive 5 in the top equation. So my x's are going to cancel when I go into the step where I add the two equations, where I combine the two equations. Okay, so 5x plus negative 5x, gone. 6 plus negative 2, 4. 60 plus negative 80, negative 20. We're going to divide that coefficient right off the y to get the solution for y, which is negative 5. So there's part of the solution. Then once you have that solution, you can finish it just like you finished when you were doing the substitution procedure. Plug it into any equation you like. I am going to plug it into the top equation. So now I'm going to go 5x plus 6y. Make sure to plug it in where it belongs. This is the value that represents y. So 6 times negative 5. Again, I'm using this top equation, and this is 60. Okay, so now this is 5x minus 30 is equal to 60. I want to solve for x here, so I'm going to bring this negative 30 over here, and it will become positive 30. So that's the same thing as adding 30, adding 30. That's what this arrow represents. This is no longer here. All you have is 5x equal to 90. And divide by 5, divide by 5, and you'll get 18. And you can write your answer like this as well. Or just give them separately like that. Okay, so for problem number 3, that would be B. B is positive 18 while y is negative 5. this down here. So that's B. And I believe for number 2, -4 is 0. That is B. Okay, moving on to number 4, where I get to use the same method, the elimination method. So for problem 4, okay, so the system is 3x minus 5y is equal to -12. And then the second equation is 6x plus 8y. Is equal to -24. Okay. 3x minus 5y is equal to 12, 6x plus 8y. Okay. So now you can either go after the x's or you can go after the y's, either one. Just to keep numbers on the smaller side, I'm going to go after the x's. I'm going to get rid of my x's. I can do so by creating a -6 right here. You can always turn the smaller number into the larger number. And you should try to do it without using decimals or fractions. That's the goal. So if I want that -6, I just have to multiply by -2, but that's going to multiply everything by -2. So it would be -6x. -2 times -5 is positive 10y. And then -2 times -12 is 24. The bottom equation, I'm going to bring it over as is. I already have what I want, opposite signed coefficients in front of the x. So once I get that to happen, I'm ready to combine the equations. So this plus this, gone. 10 plus 8, that's 18 on that y term. 24 minus 24 is 0. Divide by 18. And you get y is equal to 0. Okay. All right, so once you get y is equal to 0, go plug into either one of the equations, this equation or this one. I'm going to let's see, plug into 3x minus 5y equal to -12. That's just my choice. So 3x minus 5y equal to -12. I'm using equation 1. Okay, so then this would be 3x minus 0, which is just 3x. 3x take away nothing is 3x. That's equal to -12. And then by the time you divide that 3, you end up with an x value of -4. So our finished solution is -4 for x. Y is 0. All right, so let's see. So for number 4, that would be choice A. -4 for x and 0 for y. You can list the answer like this or like that. Okay, moving on to number 5. Okay, so for problem number 5, x minus 4y is equal to -10. And then 2x minus 8y is equal to -17. All right, now I can use any method I want. It doesn't say to use a specific method, and so I'm going to use elimination. I'm going to get rid of the x's, but you can get rid of the y's if you want. by creating a -2 right here, which means I'm going to have to multiply it by -2 because presently there's a 1 there. You're always changing the coefficients into what you want them to be through multiplication. So -2 times x, -2x. -2 times -4, +8. -2 times -10, 20. And then the bottom equation, I'm going to bring it over as is. And combine. Once you know that you have gotten rid of one of the columns, but actually you can probably see what's happening here. And when all the variables go away, you have to make a decision because that can happen in two different cases. You can either have no solutions or you can have infinite solutions. Both of them begin with all of the variables canceling. So this plus this, gone. This plus this, gone. That means you have 0 left. You have nothing left on the left-hand side. And now this is what tells you whether it's going to be no solution or infinite solutions. 20 combined with -17 is 3. However, this happens to be a false statement. 0 is really not equal to 3. So that statement that was there is false. And anytime you get a false statement while in the process of solving, that implies, I'm going to use the symbol for therefore, 3 dots shaped like a triangle, therefore no solution exists for this system. We have a term for that. It is called inconsistent. That is the terminology for a system that has no solutions. Okay, so that's number 5, which is D. Okay, moving on to number 6. Scoot closer. Okay, and problem number 6. We have x plus 2y is equal to -8. And then the bottom equation is -4x minus 8y is equal to 32. You can use any method you want. I'm going to use elimination. I'm going to get rid of the x's, but you are welcome to get rid of the y's. I'm going to do that by creating a coefficient of +4, just because I can see this one has a coefficient of -4. So multiplying the one that's here by 4 gives you a 4x. Multiplying 4 by the rest of the terms creates an 8y. 4 times 2y is 8y. And then 4 times -8 will give you a -32 on the right-hand side of that top equation. Bringing over the bottom equation as is, you'll have -4x minus 8y is equal to 32. Combine the two equations. So it's this plus this, gone. This plus this, gone. Okay, so again, our variables have disappeared. Is this a true or a false statement? -32 plus 32 is 0. Now this happens to be a true statement. Any number is equal to no other number other than itself, and that's exactly what it says. So when you get a true statement, that means that there are infinite solutions for this particular system. And you have to know how to express the solutions anytime it's a system with infinite solutions. You will let the latter variable, the one that comes last in the, not last, but you got to look at the two variables. X comes before y, so y is the latter variable. So you're going to say let me see how they are doing it. Okay, so here they're saying let x be any real number. Usually it's the latter one, and that's how your book does it. So let x be any real number, and if x is any real number, what would y be? And what you could do just to get, basically what happens is you're saying let one of the variables be any number, and then you are solving for the other variable, solve for the other variable in either one of the equations in terms of the variable that you have stated can be any real number. So solve for the other variable in terms of x. Okay, so one variable you're going to announce that it may be any number at all, which is always the case when you have infinite solutions. One variable can be any real number, and then you solve all the other equations in terms of that variable that you have announced can be any real value. Okay, so let's see, if I was to take the top equation, x plus 2y, just because it's easier to solve for x in that one than it is in this one. So I'm always trying to choose the option that has less steps. So I'm using that top equation, and I'm going to solve for x. I've announced that x can be any real number, and actually I want to isolate for y in terms of x. Let me say that right. So you're going to isolate for y by moving this x to the other side. So this will be negative x minus 8. The negative 8 was already there. I moved the x to the other side. And then divide by 2. So it's negative x minus 8 over 2. And you can give it as one fraction like this, or this expression, you can write it like this. Okay, that's if you break it up and you express it as this over this, minus 8 over this. Then it would look like this. Okay, I will take either one if it's a free response type question. If it's multiple choice, you can just let the multiple choice answers guide you. Okay, so here the answer is C. X can be any real value, and then I solved for the other variable. There's only two variables in this system, which was y, but in terms of x. In other words, you're isolating the other variable, and you should have nothing but x in it. You should have nothing but the variable that you announced could be any real number, which is what this says. Solve for the other variable, but in terms of x. Okay, so that was C, choice C. Okay, moving to 7, where there's an application problem, as well as number 8, same type of, just two different application problems. Actually, 7, let's see, I think I have room here. All right, so let's read this. It says a tour group splits into two groups when waiting in line for food at a fast food counter. First group buys 7 slices of pizza and 4 soft drinks, pays $31.49. Second group buys 5 slices of pizza and 6 soft drinks for $26.61. How much does one slice of pizza cost? Okay, so we're going to represent the things that they're speaking of in this problem. Cost of a pizza slice, which we presently do not know. and cost of a soft drink. We don't know how much that costs either. Costs. All right, so I'm representing to begin with, and then I'm going to go back, take a look at that problem again. Okay, so we have two groups. One group buys 7 slices and 4 soft drinks and pays $31.49. So I'm going to write an equation based on what the first group is spending. They buy 7 slices of pizza times the cost of a single slice, but we're multiplying it by 7 because they're buying 7. This is just the cost of 1 slice that we don't yet know. Plus that first group not only bought 7 slices, they bought 4 soft drinks, and this is the price per soft drink. And their total bill came out to $31.49. The second group bought 5 slices of pizza, and the X is the price per slice, and 6 soft drinks, and this is the price per soft drink, and their total bill was $26.61. Okay, so again, you have a system. You're going to try and solve for slice of pizza. So, you may want to get rid of the Y's. If that's the question that they're asking and you don't really need to answer both things. I mean, a lot of these problems, they'll ask you for what is the cost of a sliced pizza as well as a soft drink. But the question here is only how much does 1 slice of pizza cost? So if that's all they're asking you, you need to solve for X. So X has to remain in the problem. The other variable is what you want to get rid of. So I'm going to get rid of the Y's. Okay, if I'm going to get rid of the Y's, then I can maybe try to turn both of these to keep it, the numbers as small as possible. I can try to create 12s here. Okay, I can create a 12 out of 4 by just multiplying by 3. But remember, one of them needs to be negative, so I'm going to multiply the top by -3, which would turn this into a -21. -3 times this 4 would be -12y, and then -3 times this 31.49 is -94.47. And then to create 12s on this bottom equation for my y column, I need to multiply by 2. So that'll create a 10x. 2 times 6 will create a 12y. And 2 times 26.61 is 53.22. And once you have one column that's ready to cancel, you can go ahead and combine those two equations. So this cancels those y's. -21 plus 10 is -11x. And then -94.47 plus 53.22 is -41.25. And then we're going to divide both sides by -11. And that is 375. Divide by -11 is what I just did. And I got x is equal to 375. So that is the price for a slice of pizza. And I would find the other answer, but they didn't ask for it. So you can do as little work as possible. If they did, you would just take what the x value is and plug it into either the top or bottom equation, then solve for y if they wanted the cost of a soft drink, but they don't. So this is it. As far as which one that is, from the multiple choices, that would be 7 is D. Okay, moving on to number 8. Okay, so problem number 8. Okay, problem number 8. It says a tea shop, a tour group, sorry. No, I'm reading the wrong one. I'm mixing both of these. 8, sorry. A tea shop owner is mixing a blend of 2 teas, one of which costs $6.50 per pound, and the other tea costs $4 per pound. And the shop owner wants to mix the more expensive one with the cheaper one in order to come up with a blend that will have a price in between those two. The owner wants to have 20 pounds of the mixture that will sell for $5.50 per pound. And you can see that price is in between $6.50 and $4, which makes sense because you're mixing something more expensive with something cheaper. How much of each tea should be used? So first let's get our information organized like we did in the previous problem. A little bit more going on here. Let's see. So I'll just refer to this as brand A and brand B. Call it TA and TB. All right, so let's see. So one of these goes for $6.50. I guess I can just put it all down here. It sells for $6.50 per pound, and we do not know how many pounds of this particular type of the more expensive tea that we're going to use. I mean, that happens to be the question. The other tea, which we're calling brand B, goes for $4 a pound. And we also don't know how many pounds of that we're going to use. That's part of the question. Oops, I don't need the dollar sign. Okay, so this would be Y pounds. Okay, so we don't know how many pounds of the $6.50 per pound type of tea we're going to use, nor do we know how many pounds of the $4 per pound type of tea that we're going to use. We just want to create a mixed blend of these two types of teas. So let's see, we do know that we want to end up with a 20-pound mixture. And we want the price to be $5.50 per pound. Okay, so we can come up with two equations. First, we can say that however many pounds of this we're going to use plus however many pounds of this we're going to use has to equal the 20-pound mixture that we create. So with respect to number of pounds, we can write this equation. X plus Y is equal to 20. With respect to cost, we can write the following equation. Don't know how many pounds of brand A we're going to use, but we do know that it goes for $6.50 per pound. $6.50 times however many pounds of that particular brand we use. plus added to that cost will be what we spend on the brand B of tea. So TB. Let's see, we don't know how many pounds of that we're going to use. We just know that it's $4 per pound. And you can put the 4.00 if you want, but it's the same thing as 4. Just like here, you could write 6.5 if you wanted to. And we do know that however much of the brand A tea that we use, it'll be $6.50 per pound. However many pounds of the brand B tea that we use, it'll be $4 times however many pounds of that brand we use. And that will be equal to a cost of $5.50 per pound of the mixed blend. But for the mixed blend, we do know that we want 20 pounds. Okay, so we have two equations now, and we are going to solve this system. So let's clean this up a bit. Okay, we have x plus y equals 20. And then here, down here, we have, I'm just going to go 6.5. I'm not going to report that 0 because you don't have to. For y, and then 550 times 20, 5.50 times 20 is 110. Okay, so now if you want the decimals to go away, you can leave them in if you want to. You can multiply the whole bottom equation by 10 because you only have one decimal and that goes out to the 10th place. Or you can just leave them the way they are. I'm going to leave them as is, and I am going to try and get rid of the y's right now. They want to know how many pounds of each, so we actually do have to solve for x and y, because the last sentence in that question said how much of each type of tea should be used. So right now, I'm going to get the y's to go away by multiplying this by negative 4. I want that coefficient to be a negative 4 because this one's a positive 4. So this will be negative 4 times x, negative 4x. Negative 4 times y, negative 4y, and then negative 4 times 20, negative 80. This is going to come over as is. We have 6.5 on our x's in the bottom equation. We have a positive 4 on our y's. And we have 110 for the constant. I'm going to combine these equations now that the y's are ready to cancel. This combined with negative 4 combined with 6.5 is 2.5x. And 110 take away 80 is 30. Then I'm going to divide the 2.5 coefficient off of the x, likewise on the right-hand side. So now we have x is equal to 30 divided by 2.5, and that is 12. So for x, we have 12 pounds is needed of brand A tea. Okay, so 12 for this. We know that this plus this is equal to 20. So therefore this has to be 8 pounds. Okay, so for the 650 tea or brand A, whatever you want to call it, the one that costs $6.50 per pound, we need 12 pounds of that. The one that costs $4 per pound, we need 8 pounds. And you have to be specific when you give your answers. Okay, so for number 8, this is a free response answer, so you would just state it like this. Okay, don't just say 12 and 8, be specific. So for the 650 per pound tea, 12 pounds. And for the $4 per pound tea, 8 pounds. that's it for that problem. Okay, moving on to number 9. Problem number 9. Okay, problem number 9. We start to move into the 3 variable systems. I know those are quite a bit of work, but pretty much everything is up in sections 11.1 and 11.2. So here we go. Okay, the trick with these is to try to get rid of one variable. Try to concentrate on a variable that you would like to get rid of, and it'll be the one that seems to be easier to get rid of than some of the other variables that you're looking with. Like, for instance, variables that have a 1 in front of them are very easy to work with and to get rid of because you don't have to worry about fractions appearing throughout the work. So it's always more desirable to be trying to get rid of variables with a coefficient of 1. Whatever variable you decide you're going to get rid of, you need to get rid of it twice. So you're going to combine 2 equations together and get rid of this variable that you've chosen, and then choose 2 different equations. Well, you have to change at least one of them and get rid of that same variable. In this way, you will reduce your system from 3 variables to 2 variables. You can then find x and y as we have in problems, all the way up through number 8. We were working with systems that had 2 variables. So you're going to reduce this to a 2 variable system. Find those values the way you had in numbers 1 through 8. And then we'll go back and find the 3rd value once we find the first 2. Okay, so no way to actually make these shorter problems. You need to be able to show these by hand. Don't do these in the calculator. If there's anything that I'm willing to let you do in the calculator, I've been very straightforward about that in class, and I will voice it again here as we do the practice test. Mainly the only things I'm going to allow you to put in your calculator are some of the matrix problems that are on this test. Okay, so this was one equation in the system. X minus y plus 4z is equal to negative 23. Next equation for number 9 is 3x. There's no y term, but there is a z term. And then the last one is x plus 4y plus z, and that's equal to 7. So I would look at the fact that you already have one equation where you only have 2 variables. In other words, the y is gone. So why don't you go with the flow, follow that same vibe right into getting rid of the y term, but in a different equation, because the minute you can get 2 equations with only 2 variables, and they have to be the same 2 variables. If this one has x and z, you want to create another equation with just x and z. So you can use equations 1 and 2 to try and get rid of the y term. So I'm going to move those over here. Right now, we already have an equation that has only 2 variables, very desirable. And we're going to follow the lead that this equation is giving us. It's saying create another equation that only has x and y. In other words, get rid of the y term. That's what I'm going to go after because I can make these choices all throughout the problem. Okay, so let's see. So I'm going to be working on x minus y plus 4z. I'm going to use the 2 equations that actually have the y term in it and work towards getting rid of it. And I'm going to work it with this equation right here. Okay, so pretty simple. If I want to get rid of the y term and I see that this is 4, this one needs to be negative 4. It already has the negative, so just multiply it by 4. So what I'm going to have at that point is 4x minus 4y. I'm just using this 4 multiplier and distributing it throughout the entire equation. So it'll be 4x minus 4y plus 16z is equal to 4 times 23. That's going to be 80, negative 92. You might want, I'm going to check these as we go along because there's so many places that you can make a mistake with these problems. So 4 times negative 23 is negative 92. And then the equation below it, which it's about to cancel the y's with, is x plus 4y plus z is equal to 7. And then I'm going to combine these. So these are going to combine. The y's are canceling. We have 5x. We have 17z. 16 plus 1 is 17 on our z term is equal to negative 92 plus combined with 7. And that will be negative 85. So we want to concentrate now on these nice equations, the ones that are providing hope at this moment, that only have 2 variables. The one that I just created by using equations 1 and 3. This was equation 1. This was equation 3. And I stuck to the theme of getting rid of the y's. I had the idea to get rid of the y's because it was provided by this middle equation that did not have a y. So I just kept on with that particular theme. So go and grab that equation right there that gave us the idea in the first place, and we're going to pair it up with the equation that I created that has x and z. So I'm going to put that right here. 3x plus z is equal to negative 5. And now let's work with this reduced system where I've taken it from 3 variables to just 2. And let's find whichever value you think is easier. I think what I'm going to do is, let's see, it doesn't really matter which one you go after. If you try to get rid of the z's now, because now you can make it. Now you need to make a choice about getting rid of the x's or the z's. It would be easier to get rid of the z's because all you would need is a negative 17. Whereas if you go after the x's, you're going to have to make both change. You're going to have to change both of these. One would have to be negative 15, and the other one would have to be positive 15. So I am going to create negative 17 right there by multiplying by 17 because presently it's a 1. So that would give me, and I'm going to finish over here and keep working this way, the equation that's highlighted in yellow, 5x plus 17z is equal to negative 85. And then the one that I'm creating below it is going to be negative 51x. And then negative 17 times z would be negative 17z. And then negative 17 times negative 5. Negative 17 times negative 5 is 85. Okay, and now I'm ready to combine these equations, and that's because the z's are ready to go. So now I have 5 take away 51. 5 take away 51 is negative 46x is equal to this plus this is 0. All right, so now solving for x by dividing by negative 46, and I have x is equal to 0. So I have one of the 3 values so far. Now what you should do is continue with your two variable system. Don't go back to the three variable system yet. We'll go back there at the end. I want you to continue with this two variable system that we had come up with. Here it is right here. Okay, we had 5x plus 17 is equal to negative 85, and then this equation that they gave us, 3x plus c. You can use that system with the zero that you have just found. Like you can plug the zero into either the equation we created or to the one they gave you. I'm going to use the one that they gave us. Okay, just use one of the equations. Choose an equation to use from your two variable system. Okay, so I'm going to use 3x plus z. Before I altered it with the negative 17, it was 3x plus z equal to negative 5. I'm going to stick with that. I'm going to go put my 0 in for x and solve for z. And in this way, I will know my second value. Okay, 3 times 0 is 0. 0 plus z is just z. So now we know that z is equal to negative 5. And now I have two values. As soon as you find that you have two values, now you can go back to the main system. Okay, and you can choose any equation that has the variable in it that you still need to solve for. We have x and we have z, therefore we need something with y in it. Any equation that contains y. That's up to you which one you want to choose. Try to make smart choices. Choose the easiest one you can, the one that looks the easiest to work with. So let's go back up here to the main system. We need something with a y in it because it's the only variable that we have not yet found the value for. Okay, so this y has a 4 in front of it. This one has a negative in front of it. It's up to you which one you want to use. I don't know if you consider either one of those easier, or I'm going to use the top equation. So here I'm going to write my choice, x minus y plus 4z is equal to 23. That's what I have chosen to work with. And I'm going to plug in the values that I know and solve for the one that I don't know. So x, I happen to know that that is 0. Y, I do not yet know. And z happens to be negative 5. Okay, so this will be 0 take away y is just negative y. This times this, that's a product right there of positive 20. Just moving this over here. This is negative 43. Okay, so we have our triple ordered pair. We had x is 0, z is negative 5, and y turned out to be negative 43. Let's see if I plug this in right. Okay, so I chose x minus y. Let's see, what number is this? This is number 9. All right. Now let me check my work because I think something went wrong with the last answer. X is good, Z is good. Excuse me. So x minus y plus 4z is equal to negative 23. I think I copied that, right? X minus y. Oh, I see what I did wrong. When I copied this right here, I copied the equation right, but then I copied a minus here instead of a plus. So plus, this should have been negative 20. Positive 4 times negative 5 should have been negative 20. Therefore, this should have been positive 20. This should have been positive 20. Therefore, when I added this to this, I should have gotten just negative 30. Okay, so that is the z value, or the y value. Do a double mess up here. Okay, so x turns out to be 0, y turns out to be negative 3, and z turns out to be negative 5. Okay, I think I got that right. And then let's see. This is B. 0, 3, and negative 5. They have positive 3. What did I have? Let's see what I got for that. This problem's giving a hard time. So 0 and negative 5 is right. X is right. Z is right. And then I copied this equation from number 9. X minus y plus 4z is equal to negative 23. Check it one more time, but I think that I plugged into it correctly. So 0 minus y, and my y value I didn't know yet. And then it was positive 4 times negative 5, and that is negative 20. And then I see. Wow, really messed up on this one. Yep, I copied it wrong twice. Okay, so this was negative y. Okay, so now I've copied everything right. This was negative 20. There was a negative in front of the y. So divide by negative 1 to get rid of that coefficient. Divide by negative 1, and you get y is equal to 3. All right. All right, so that's number 9. 0, 3, negative 5. Okay, let's do number 10. Okay, problem number 10, same type of problem, I believe. Okay, this one starts with, I'm going to copy it up here because there's so much work in these. All right, so number 10 is 4x plus 3y plus z. equal to negative 15. Okay, then this would be 3x minus 5y minus z is equal to negative 15. And then third equation is 4x plus y plus 4z is equal to negative 23. So that's your system there. Let me make sure I copied it right. 4, positive 3, positive z, negative 15. Then it's 3x, negative 5y, negative z, and negative 15. Then it's 4x, 1y, positive 4z, and negative 23. All right. Now this one, unlike the last problem, you don't have a hint of which way to go because there's no equation that's missing a variable, so it's just your choice. You can either get rid of the x's, you can get rid of the y's, you can get rid of the z's. That's when you're going to want to start looking at each of the equations and seeing, hey, are there any variables that specifically have ones as the number 1 as a coefficient, either positive or negative 1? Is there a particular variable that has more of that going on? And that would seem to be the case for the z's. You have 2 of your z variables having coefficients, one's a positive one, the other one's a negative one. So they're going to be a little easier to manipulate than the y's or the x's. So I'm going to go after the z's. I'm going to try and get rid of the z's. Okay, right now I'm going to be using equation 1. I'm going to start off by using equation 1 and equation 2. And that's because I can see that these two equations are already ready to go with respect to getting rid of the z variable. So it's 4x and separate it from the main system because otherwise it's going to get very messy. Okay, so 4x plus 3y plus z is equal to negative 15. That's equation 1. Okay, this is equation 1, equation 2, equation 3. Just numbering them like that. Okay, and then equation 2 is 3x minus 5y minus z. You can see that those variables are already ready to cancel, the z variables. So you can go ahead and combine these two equations. This z cancels with this, and you end up with 4x plus 3x, 7x. Positive 3 and negative 5, negative 2 on your y variable, and negative 15 combined with negative 15 is negative 30. So right now you have an equation that only has 2 variables in it. Now you want to create another one just like that. So stick to this theme. Pick a variable to get rid of and stick to it twice, working with the main system each time you try to get rid of whatever variable you have chosen to get rid of. Okay, so again, I am trying to get rid of the z's. I just used equation 1 and 2, so you can't use the same 2 equations again. You have to, one of them you have to change. I'm going to use, I believe this time, just because, rather than this one, is just because I want to get rid of the z's. I know one of them has to be negative. I want that to be a negative 4, so I'm just going to use equation 2, multiplying it by 4 to create that negative 4, and I'm going to use equation 3. Okay, so here is equation 2 and 3 this time. So I've changed at least one of the ones that I'm using. Okay, so I'm going to take equation 2, remove it from the main system. Spread this out so much because I have a lot to do here. And then that was equation 2, 3, negative 5, negative 1, negative 15. And then equation 3 is 4x, positive 1y, positive 4z, and negative 23. And to create that negative 4 right there, I'm going to multiply this by positive 4. So this will come over as 4 times 3, 12x, 4 times negative 5, negative 20y, 4 times negative z, negative 4z, and 4 times negative 15, negative 60. Bring the other equation, the bottom equation over as is. 4x plus y plus 4z equal to negative 23. Okay, now you're ready to combine the equations since you can see that you've arranged it so that the z's are once again going to cancel. Okay, so now combining, we would have 16x. Negative 20 plus 1 is negative 19. And then this plus this is equal to negative 83. And so now we have another equation that only has 2 variables. So now what we want to concentrate on is the system that we have now made possible that only has 2 variables. Okay, so your 2 variable system is now 7x minus 2y equal to negative 30. And then your other equation that has only 2 variables is 16x minus 19y equal to negative 83. And let me just make sure that I multiplied all this right. That's going to be 12 minus 20 minus 4z and negative 60. The bottom equation was 4x plus y plus 4z negative 23. When I added these, I got 16. When I added these, I got negative 19. These were gone. These gave me negative 83. Okay, now moving to this 2 variable system, you can either get rid of the x's or the y's, whichever one you want. It's going to be equal amount of work either way. So let's see. If I wanted to get rid of, I'm going to go after the y's. Okay, if I was to double this, I would get a 38. And I can turn 2 into 38 also by multiplying it by 19. So I'm going to multiply this by 2, thus creating negative 38y, and I'll multiply this by 19. 19 times negative 2 would be also negative 38. So one of these needs to be positive. Okay, so let's see, maybe I could do this one as the negative. That way I'll have a positive 38 and a negative 38. Okay, let's go ahead and multiply everything in the top equation by 19. So it's 19 times 7 for this first term, and that's 133x. And then 19 times negative 2 is negative 38y. And then 19 times negative 30 is negative 570. And then on this bottom equation, okay, so this would be negative 2 times 16, negative 32x. And then negative 2 times negative 19 is going to be positive 38y. And then negative 2 times negative 83 is going to be positive 166. All right, now since the y's are ready to go, we can combine these 2 equations. These cancel. 133 minus 32 is 101. 1 on your x's, and then 570, negative 570 combined with 166 is negative 404. Okay, almost to the answer for x. Divide by 101, divide by 101. And you get x is equal to negative 4. All right, one answer. So now continue. Stay on this two-variable system. Continue with your two-variable system. And you can use either 7x minus 2y equal to negative 30 or 16x minus 19y equal to negative 83. I'm going to use the 7x minus 2y equal to negative 30. I already know what x is, so I'm going to go put that right in there, and I'm going to solve for y. So this will be negative 28 minus 2y is equal to negative 30. We're going to bring the negative 28 over here, at which point it will be positive 28. We'll have negative 2y is equal to negative 2. Divide by negative 2 on both sides, and you'll have y is equal to 1. Okay, so we have two answers. Now, when you have two answers and all you need is the third one, then you can return to the three-variable system. And you can choose any of the equations from the three-variable system that you want to choose. Okay, so let's see what looks good. All of them are sort of a pain. I'm just going to use the top one. So 4x plus 3y plus c. 4x plus 3y plus z is equal to negative 15. And I'm going to go and put the answers in that I have discovered thus far. I know that x is negative 4. I know that y is 1. And all I have left to find is z. Okay, so it's 4 times x plus 3 times y plus z is equal to negative 15. So this will be negative 16 plus 3 plus z is equal to negative 15. This will be negative 13 plus c when you put the negative 16 and 3 together. And then by the time you move the negative 13 to the other side, it becomes positive 13. Okay, so at that point, you have z is equal to negative 2. All right, so we have to look for an answer that has x as the negative 4, y as the 1, and z as the negative 2. And that'll be our final answer, and hopefully there's an answer like that. Okay, so this is number 10. So let's see, we got negative 4, 1, negative 2. And that would be B. All right. They're monsters, those problems. But let's just be happy that they're not 4 variables. So those are even longer, obviously. So you need to be able to show those by hand. Okay, let's move on to number 11. And I am going to have to stop this video shortly just because it's running pretty long. I didn't think it would take that long to get through the first two sections, which is problems numbers 1 through 28. But I'll have to pick up with number 12 in the next video. Okay, so here's number 11, also a 3-variable system, x plus y plus z is equal to -1, and you have x minus y plus 5z is equal to -1 also, and then the last equation in that system is 5x plus 5y plus 5z, and that's equal to 7. Okay, so for number, just make sure that, number 11, you need to just make sure that I copied it right. X plus y plus z is -1, x minus y plus 5z is -1, and 5, 5, 5, and a 7. Okay. Okay, so again, there's in this problem, like number 10, there's no equation that's missing a variable, so we don't have a hint there. I think what I'm going to do is go after, you can go after either the x's or the y's, it's up to you. I'm going to go after the y's. But it's your choice. You can go after the z's if you want to. I just like that there's the positive and negative thing happening already. So again, I have equation 1, equation 2, and equation 3. And I think I'm going to start this off by working with equations 1 and 2. Okay, so I'm going to get rid of the y's, and I am using equation 1 and 2. I'm going to separate them from the main system. This is equation 1. This is equation 2. We're ready to combine, and that's because the variable that I wanted to get rid of, they already have this opposite coefficients in front of them. So 1x plus 1x, as I combine these, 1 plus 1 combined is 2x. This and this cancels. And then 1z plus 5z is 6z. -1 combined with -1, -2. Okay, so I already have one equation that only has 2 variables rather than 3. Now I'm going to go after 2 other equations. I have to change at least one of the equations from what I just used just a minute ago. So I think I'm going to use equation 2 and 3 this time. Okay, again, I'm still trying to get rid of the y's. And I am going to use equation 2 and 3 this time. Okay, so equation 2 is x minus y plus, or x minus y plus 5z is equal to -1. And then equation 3 is 5x plus 5y plus 5z is equal to 7. So if I want the y's to go away again, just like I had in my original plan, you want to stick to that plan twice in the main system. That means I'm going to need to multiply the top equation by 5. So that I end up with a -5 in front of my y as opposed to the +5 in front of y in the lower equation. So this is going to be 5x minus 5y plus 25z. It's multiplying everything by 5. 5 times negative 1 is negative 5. Bring over the bottom equation as is, which is 5x plus 5y plus 5z is equal to 7. And now since these y's are ready to go away, you can combine the two equations, leaving you with 10x plus 30z is equal to 2. And now you have another equation. That has only two variables, just like the equation above. So now we're going to go into our two variable system, which we have created in the previous two steps. And we're going to just bring those equations into our system. This will be 10x plus 30z is equal to 2. Okay, so now I can either solve for x or I can solve for z. I think what I'm going to do is I'll just go after the x's. Okay, so I'm going to try and get rid of the x's. And if that's going to be the case, I need this top one to be a negative 10. So to make that top coefficient on my x's a negative 10, I'd have to multiply by negative 5. So that would give me negative 10 on my x's. Negative 5 times 6 is negative 30z. And then negative 5 times negative 2. So my constants on the right side would be, let's see, positive 10. Okay, negative 10, negative 30, and then this would give me positive 10. Bottom equation I'm going to bring over as is. 10x plus 30z is equal to 2, and perhaps you can see what's going to happen here. I've gotten these x's to cancel, but in the process of attempting that, the z's also went away. So I have 0 on the left side of the equation, and when I add up the constants, I have 12 on the right side of the equation. This is a false statement. And if you get a false statement, even in your two-variable system, that means the entire main system is inconsistent. In other words, it does not have a solution. So, no solution exists for the main system. Learn the word for that. When there is no solution, the term is inconsistent. Okay, that's implied by a false statement in the solving process. So for number 11, that would be choice D. Still have to show all the work for the three-variable system. Okay, I'm going to stop this video right here at problem number 11, and the next video we'll pick up with numbers 12 through 28.